Alright, so for this video, I'm going to be solving the equation x to the power of 4 is equal to negative 9. So what I'm first going to do is add 9 on both sides. So then these two cancel out, and I get x to the power of 4 plus 9 is equal to 0. Now from here, I can rewrite x to the power of 4 as x squared to the power of 2, and I can rewrite 9 as 3 squared. And if I have something in the form a plus b squared, this is equal to a squared plus b squared plus 2ab. And if I have something in the form a squared plus b squared, then this must mean that this is going to equal a plus b squared minus 2ab, because this is the same thing as this without the 2ab. So this means that a is equal to x squared and b is 3. Going back over here, so I get x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared. And this turns into x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared minus 2 times x squared times 3 is equal to 0. So now from here, I get x squared plus 3 squared minus 6x squared is equal to 0. And remember how the square root of 6 squared is equal to 6. So what I'm going to do is I'm going to rewrite this as x squared plus 3 squared minus the square root of 6x squared is equal to 0. And the reason I did that is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, this turns into x squared plus 3 plus the square root of 6x times x squared plus 3 minus the square root of 6x is equal to 0. So this gives me two equations. I have x squared plus 3 plus the square root of 6x is equal to 0, and x squared plus 3 minus the square root of 6x equals 0. So for both of these, because both of these are quadratic equations, you can use the quadratic formula to solve them. So by using the quadratic formula, I'm actually not going to do that in the video, but you can try that yourself. You should get that x is equal to the square root of 6 times negative 1 plus I over 2, and x is also equal to the square root of 6 times negative 1 minus I over 2. And also, along with this, you should get x is equal to the square root of 6 times I plus 1 over 2, and x is equal to the square root of 6 times times 1 minus I over 2. So these are your four solutions. Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now, 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000, so I get 1000 squared plus 23 times 1000, and now I can distribute 25, so I get 25 times 1000 plus 25 times 23. Now 1000 squared is equal to 1 million, so I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem.